So I'm making a badge. It's part of a competition. There are a few YouTubers doing it. I don't know how you're going to hear about it. Sion, any idea? The Unexpected Maker's running it. So he's come up with the rules. Not that I can remember them or will probably follow them. But we've got to make a badge. So I've never done that before, but I thought it'd be fun. So this is what I'm doing. So I've been working pretty hard on what's going to become a badge. Now this is, hopefully you can see those LEDs flying by. They're pretty dim, and that's because I'm running it at quite a low voltage at the moment. So it's currently running at 2.5 volts, and it is drawing, I don't know if you can read that properly, let's just move that out of the way, 134 microamps. Now I can switch it into milliamps mode and it will give you 0.2, what was it, microamps? 120, or some accuracy differences there, isn't there? And they're brighter now. So there's this voltage drop. I just hit the camera, sorry. There's a voltage drop you get on the microamps range and the amps range. So 2.6 into the microamps range, 2.5. So we're dropping about a volt, not a volt, 0.1 of a volt. And that does make a big difference. So look at the LEDs. If you'll focus, come on now. Focus, there we go. So I'm going to change from microamps to milliamps. So like a massive change there. So milliamps is the range that I'll use, in fact. So let's have a look. 0.19 milliamps. Yeah, so a lot, not a lot. Anyway, we're using 2.69 volts, and my power supply says it is at 2.7, so it's pretty accurate. So this is reading on the other side of the current measurement. So I'm reading after the voltage drop. So anyway, this is going to be a badge. Focus. There we go. It's going to be a badge. And what I wanted to have was, this is complaining. There we go. What I wanted to have was a lot of LEDs. And so I've got a, what is it, a 4026? 4020, oh no, it's a 4017. So I've got a 4017 on there, which is a sort of decade counter with a decade output. So 0 to 9, so 10 outputs. And so I have 10 LEDs here. And you can see I've got them all connected to the same IC. And the way that I'm flipping between the two rows, so this would be, I don't want to give the whole thing away, but I wanted to have quite a few LEDs running in a sequence. And so I've got a push button over here for the clock, and it's connected to a 4027, which is a JK flip-flop. I've used that before. And so we're sort of switching the output side. Now I did just try, you can probably see the remnants of it down there. I did just try and make a simple sort of oscillator, but it worked, but it drew 2 milliamps. And partly that's because we're charging a capacitor, discharging, charging a capacitor, discharging. So we're using a little bit more power than I wanted to. And it also wasn't running very fast. And I tried to change the RC timer. It's a resistor capacitor timing circuit, which is the thing that makes this thing flash. But it didn't work very well, so I gave up. And instead I'm going to use a 555 timer. Now I avoided using a 555 timer. I've got a couple here. Oh, you won't be able to, there's absolutely no way this is going to focus on that, is there? No. Let me just sort that out. So if it's possible for you guys to read that, that is a KA555, and the other one is an NE555. But the problem is they sort of require 4.5 volts to run, and because this is a badge, I need it to run down to a pretty low voltage. Now I'm looking at 2.69 there. If I was going to go for a 3 volt coin cell, then that's as far down as I'd want it to go, really. It's not going to be able to provide a lot of current at that voltage anyway. So they sit around 3 volts. So that's as low as I want it to go. So I'm going to pick up a CMOS one. And I think I'm going to go with the TLC 595. Have I just said 595 a lot? Whatever. You know it's 555 timer. Anyway, so this is currently where I'm at, is flip-flopping on a 4017